Today we're going to take a look at glancing collisions and two-dimensional collisions when it comes to conservation of momentum. To do that, we'll use this two-dimensional air track, this air hockey type table that has little holes in it that push air through it and create a bed of air on the surface. What we will do as we go through this lab activity is we will place on there various pucks, and we can stack them together so that they have twice the mass. So one puck has a certain mass, two pucks have twice the mass, and we can see how the collisions occur. I'm going to turn on the air supply, and you will see very quickly that this is a very low friction environment. The minute I turn the air off, this comes to rest. If I try to push this across the surface with the air off, it doesn't even make it halfway. But with the air on, it will bounce for a very long time back and forth. So what we're going to do is I'm going to treat this as a glancing collision. I am going to start off by placing the puck here in the middle. I'm going to take the second puck and I'm going to slide it directly at it, trying to get a linear collision to demonstrate that type of action-reaction sequence. And you'll notice that the red puck slows down and the blue puck takes off. Now, with a glancing collision, what's going to happen is the red puck is going to come in, it is going to hit the side of the blue puck. The blue puck is going to move off in this direction. Note the red puck initially had no y direction. If we assume that this direction is x and this direction is y, it had no y direction. And so when this comes in, it is going to gain a y component, and that is going to lead to the y component going over to the right. The amount that it is going in the y direction is going to be equal in magnitude opposite in direction of the blue. The x component of the red will slow down. The x component of the blue will speed up. Here we go. Here's a glancing collision. Okay, we'll see that again. And you can see that the red puck veers off in that direction. Now, what happens when I do the same thing, but I have twice the mass? There's twice the momentum on here, twice the mass. And so we slide it along, and we see the red one actually maintains its direction more than when we had the single puck, and it also maintains its velocity more. Watch it again. It doesn't veer off as much. I'll take off the mass. We'll see it again. Oops, I missed it. We'll see it again. And you can see it, the red one takes off in the y direction more because the momentum that it initially had was less than when there were two pucks. Same thing will happen when I switch the orders. I'm going to make more mass here, so the blue one will start off with the blue one, one red and one blue. Hit it on the side enough, but one red and one blue. And you can see that they go off in their respective directions. What do you think is going to happen when I have more mass here with the red one? Is the blue one going to stay more straight, or is it going to veer off more in the y direction? Let's see. Let's watch that again. We find that the blue one does veer off more in the y direction than the red one veers off in the y direction, and that is because this has twice the mass of the blue puck. So this is conservation of momentum. If you have any questions, as always, please let me know, and I'll send you off with a series of collisions. Have a wonderful day.